Hello, grade 12. In today's lesson, we're going to be looking at trigonometry, simplifying trig ratios, and without any further ado, let's just get right down to the lesson. Okay, we have our question there. It says simplify the following without using a calculator. And for the first question, we are given sine 10 degrees and then cos 120 degrees over cos 80 degrees and then sine 150 degrees. Now looking at sine 10 and cos 80 degrees, we can see that the angles we are working with here are non-special angles, right? Then when you are working with angles that are not special angles, what you want to do is you want to change one trig ratio using the fact that this sine and cos are cofunctions. So we want to change at least one of these trig ratios to look similar to the other one so that we have them to cancel out, right? Because remember, we cannot use a calculator. But now when we look at this one, cos 120 degrees and sine 150 degrees, we can see that if we use our reduction formulae for the second quadrant, because they're both in the second quadrant, we can produce special angles for this one. Say maybe, for example, if you say 180 minus 60, 60 is a special angle. If you say 90 plus 30, 30 is a special angle. So we can see that these two angles will produce special angles, which we know we can calculate those without any use of a calculator. So now let's begin. We want to change this one. Our choice, let's say now we leave sine 10 the way it is. Now let's try to write this one in terms of the reduction formulae. So we have 180 degrees minus 60 degrees. So the reason I'm using this one, I'm avoiding having to deal with a lot of cofunctions. So I'm choosing that one because with this one, remember, I know that I do not have to remind myself of changing this cos, right? Then for cos 80 degrees, I will write this one as cos 90 minus 10 degrees, right? Now when I write like this, I know this will become a cofunction. And then for sine 150, I can write it as 180 minus 30 degrees using our reduction formulae. Then I have sine 10 degrees and then cos 180 minus 60. So cos in the second quadrant is negative, so that means I have negative cos 60 degrees, and then all that over cos 90 minus 10 degrees. Remember, now this will change to its cofunction, and then this becomes sine 10 degrees positive because cos is positive in the first quadrant. Then for this, we have sine 180 minus 30 degrees. We know sine is positive in the second quadrant, so this will become positive sine 30 degrees. Now at this point we can see our numerator is now the same as the denominator. Now we can cancel out this. We no longer have that problem of the angles that are not special angles. Then above there we are left with cos 60 degrees and then over sine 30 degrees. Now we know having to use our triangle for special angles, we know that cos 60 degrees becomes half, so that's negative 1 over 2, and then all that divided by sine 30 degrees also is 1 over 2. Remember, cos 60 and sine 30, they are equal. Then what is negative half divided by half? That will give us negative 1. Okay, now let's solve B. We have cos A minus 360 degrees and then multiply by sine of negative angle A and then over tan A cos 180 degrees. Now we know when they've written like this indicates a negative angle, because remember the notation we are used to is 360 degrees minus A. Now if they start with A and then say minus 360 degrees, this indicates a negative angle. So now to show that it indicates a negative angle, we're gonna write it like this. So we're just gonna factor out the negative, then we have 360 degrees minus A, right? And then close the bracket. Now what is sine of a negative angle? We know sine of a negative angle is equals to negative sine A. And then over, if we can just break this down from grade 11, we know that we can break tan A to sine A over cos A. Now from our knowledge of special angles, we know that cos 180 degrees is negative 1. Or you can even just use the graph of cos. It will show you that for 180 degrees we have negative 1. Then is equals to cos of a negative angle is positive. So here we have cos A and then times negative sine A, and then over. So for this one we have sine A over cos A times negative 1, which will give us negative sine A over cos A. Now at this point we want to write in a way that we can see what will cancel out here. So we have negative cos A and then times sine A. We can do the reciprocal for this one, whereby now we use the multiply sign and then say cos A over negative sine A. Now at this point we can see the negative and the negative will cancel out, and then we also have the cancellation of sine A and sine A. The negative and negative, then we'll only be left with cos A positive and cos A here. So that will give us cos squared A. Now at this point we have simplified to one trigonometric ratio. Okay, let's solve C. So for C, we can see that we are given 2 cos 105 degrees, cos 15 degrees, and we are given cos 45 degrees minus x, cos x minus sine 45 degrees minus x, and then sine x here. So now looking at this, you can see that here we are working with a certain kind of compound angle, because if you can check your formulas for compound angle, here we have cos, and then we can see the angle 45 degrees minus x, also here 45 degrees minus x, and then here we have x and x. So we can all agree here that we are working with this compound angle cos A plus B, which goes cos A cos B minus sine A sine B. So if you look at that, you can see that it is quite similar to this one, whereby if we say 45 degrees minus x represents A, that's where we have it, and then x represents B, so that's A again and that's B again, right? So now let's deal with this one. We have 2 cos, and then this is 105, right? Remember 105 is in the second quadrant, so we can use our reduction formulae 90 plus theta or 180 minus theta. But looking at this, we can see that we have 15 degrees here, and we at least want to change it so that it would be similar to that one, the angles. So we can just use cos 90 plus 15 degrees, which obviously gives us that 105. Then we have times cos 15 degrees over so for that one we have cos, remember it must reduce to A plus B, so our A is 45 degrees minus x and then plus x, right? So x being our B, angle B. Then this is 2 cos 90 plus 15 degrees. We know that cos is a cofunction of sine, so it changes to sine, but then we know that cos is negative in the second quadrant, so this should be negative sine 15 degrees, and then times cos 15 degrees times cos 15 degrees. Then over, we have this one, it becomes negative x plus x. They cancel out, so we are only left with this cos 45 degrees. So cos 45 degrees. Now, let's deal with this one. We have negative 2 sine 15 degrees and then cos 15 degrees over cos 45 degrees. Now, if we look at this one, we can see that this is a double angle. Right, looking at our formula sheet, we have sine 2a is equals to 2 sine a cos a. Now we can see that here we are provided with something similar to that. You can see this is 2 sine 15 degrees cos 15 degrees, which corresponds to this. That means it must reduce to the double angle. So for this one, we have negative, remember we have this negative here, and then sine. This means that if we have an angle here, for the double angle, it should be twice the angle that we are given here. So we are given 15, and then this should be twice the angle there, so that's 30 degrees. Then cos 45 degrees. Now we can see we are now working with special angles, so we go to our table for special angles. What is the value for cos for sine 30 degrees? So for sine 30 degrees, our value is negative 1 over 2, and then divide that by 1 over root 2, which is the value for cos 45. Then we have negative 1 over 2 multiplied by root 2 over 1 if we do the reciprocal. Then negative 1 times root 2, that's negative root 2, and then over 2 times 1, that's 2. So that becomes our solution. Okay, so looking at D, we are given tan 480 degrees, which we can see that this 480 degrees is greater than 360, and we cannot tell the quadrant it is in. So now we're going to try to take this 480 degrees and subtract 360 so that we find in which quadrant it belongs in. So whenever you are given a number that is greater than 360, just subtract 360 from it. Then we have tan 120 degrees after subtraction, and then multiply that by sine 300 can be written as sine 360 minus 60, considering the fact that it is in the fourth quadrant. Then times cos 14 degrees, and then sine of a negative angle here is negative sine 135 degrees, because sine of a negative angle is negative. Then over sine 104, we are given sine 104, which we can be smart about it and write it in terms of 90 plus theta, given the fact that we have cos 14 degrees here. So we want to change this one so that we can cancel out the non-special angles, right? So writing sine, let's say sine 90 plus 14 degrees. So we are using the fact that sine and cos are cofunctions. So we know this sine will change to cos. Then we have cos 225 degrees, which for this one we're going to use 180 degrees plus 45 degrees. Now with this one, I'm avoiding using 270 minus theta. So always in the third quadrant, you should avoid using this one. Avoid using 270 minus theta. And also in the fourth quadrant, avoid using 270 plus theta, because these ones work the same as 90 minus theta and 90 plus theta. These are your complementary angles. But then when working with these ones, in grade 11 and 12, they do not allow you to do that one. You are only given the complementary angles of 90 minus theta and 90 plus theta. So you should always avoid using these two, right? Now let's continue. We have tan 120 degrees, which can be written. Now we can see that this is in the second quadrant. So this can be written as tan 180 degrees minus 60, which is a special angle. And this one, how is sine in the fourth quadrant, is negative. So we have multiply by negative sine 60 degrees. Then we can just write our cos 14 like that. And then let's try to write this in reduction formulae. So this will be 180 degrees minus 45 degrees, which is a special angle. Then for this one, we have 90 plus 14. How is sine in the second quadrant? We say sine is positive, so it will change to its cofunction, cos 14 degrees and positive, right? Because sine in the second quadrant is positive. Then here we have cos 180 plus 45. This is the third quadrant. How is cos in the third quadrant? Negative cos, right? So negative cos 45 degrees. Now at this point, we only want to be left out with the special angles. So let's continue. Here we have negative tan 60 degrees, because tan in the second quadrant is negative, and then multiply that by negative sine 60 degrees, and then cos 14 degrees. Then this one, sine in the second quadrant is positive, but remember we have the negative here, so that's sine 45 degrees. Then over cos 14 degrees times negative cos 45 degrees. Now at this point, we want to cancel out all these non-special angles, the non-special angles. So cos 14 and cos 14, they're the same, they can just cancel out. At this point, I'm only left with the special angles, so I can refer to my right angle triangles of special angles, whereby for tan 60 I have root 3, so that's negative root 3, and then for sine 60 I'm given negative root 3 over 2. So the negative is coming from here. Sine 60 is root 3 over 2. Then here I have the negative coming from here. What is sine 45? It's 1 over root 2. Then over, remember cos 45 is also 1 over root 2. But I have the negative there. So if I have to multiply everything that's here in the numerator, I have negative root 3 times root 3, that's 3. Positive 3 times negative 1, that's negative 3, and then this 2 times root 2, it will give me 2 root 2. Then divide that by negative 1 over root 2. So that's a divide, and then that should give me, if I write it in terms of reciprocal, I have this 2 over negative 3 over 2 root 2 times negative root 2 over 1. Now the root 2 and root 2 will cancel. Negative and negative is a positive, so I have 3 over 2. So that becomes my solution. Okay, so now let's look at E. We are given sine 104 degrees and then bracket 2 cos squared 15 degrees minus 1. And then here we are given tan 38 degrees sine squared for 12 degrees, right? So in this case, you can see that if we are to look at this 104, 104 is in the second quadrant, which can be changed by using 90 plus theta, and also again 180 minus theta. But if we want to change it to 90 plus theta, this is 90 plus 14. Now we have to look at the relationship between the numbers here. If we have 14 times 2 is 28 degrees. It doesn't produce this angle here, right? So here we have 38 degrees. We want an angle that will form that will have some kind of a relationship with this 38 degrees here. So let's try 180 minus. So if we say 180 minus 76, we can see now that 38 to 76, 76 becomes a double angle of 38. If you say 38 multiplied by 2, you get this 76. Now remember, with grade 12 questions, you want to you want to reduce your angles in a way that you'll produce double angles, or in a way that you'll have compound angles, right? So now let's begin. We have sine. We have decided that we're going to use 180 minus 76 degrees. Then for this one, if you look at this one, you can see that this one resembles a certain double angle that we have. So this is cos 2 theta, which changes to 2 cos squared theta minus 1. If you look at this, you can see that it is similar to what we have here. This is 2 cos squared 15 degrees minus 1, which taking back from here, it can go back to the double angle here. So that means we can write that one as, since we have 15 degrees here, the double angle of 15 is 30, so we're gonna write that one as cos squared cos 30 degrees, right? Double angle, so cos 30 degrees. Now, okay, what do we have here? We have tan 38, so tan 38 we can write it as sine 38 degrees over cos 38 degrees. Now we can see that we have sine squared 412 degrees, which we can see that if a number is greater than 360, we have to take that number and subtract 360 from it, right? So now if we say 412 minus 360, we get sine squared 52 degrees. Now let's work it out. So how is sine in the second quadrant? We say sine in the second quadrant is positive, right? Hence we have sine 76 degrees. Then what about this one? Here we have cos 30 degrees, right? Then let's solve what we have here in the denominator. This is sine 38 degrees over cos 38 degrees. Now looking at this one, we can see that we have 52, which doesn't have a relationship with any of the angles that we have here. Now let's change this 52 degrees in terms of the reduction formula of the first quadrant, because 52 is in the first quadrant. So in the first quadrant we have the reduction formula 90 minus theta, so there will be 90 minus 38 degrees. If you say 90 minus 38, it gives you that 52. But why are we doing this? Because we are trying to produce a 38 degree that will cancel out with one of this, right? Now looking at this, remember we said 76 degrees is a double angle of 38 degrees, right? So 2 times 38 gives us 76 degrees. But if you look at this, this is a double angle of sine. A double angle of sine goes as sine 2 theta is equals to 2 sine theta cos theta, right? So we can change this one to that. So we're gonna write it as 2 sine 38 degrees times cos 38 degrees. Then the cos 30 degrees, we know this is a special angle. So I'm changing cos 30 degrees according to our right angle triangle special angle. This becomes √3 over 2. Right, so cos 30 degrees gives you √3 over 2. Then over sine 38 degrees cos 38 degrees. Then here, what are we gonna have? We're gonna have cos. Remember, when we have 90 degree minus, then this one changes to its cofunction. So, but then it's gonna be cos squared 38, which can also be written as cos 38 degrees times cos 38 degrees. Right, now at this point we can see that the cos 38 will cancel out with this cos 38, but this cos 38 up here in the numerator also cancels out with this cos 38 here. This sine 38 degrees cancels out with this sine 38 degrees. Now we are only left with 2 multiplied by √3 over 2, which will give you this 2 here. We can see that it will cancel out with the 2 there, and then our solution will be left out as √3. Nice. Okay, so let's look at F. For F, we are given sine 90 degrees plus theta, which we know this will change to its cofunction, cos theta, positive because sine is positive in the second quadrant, so its cofunction is also positive. Then here we have cos 180 degrees. This gives us -1, and then multiply that by sine of a negative angle is negative sine theta, so multiply by negative sine theta over what is sine 180 degrees. So using our graph, we know that sine at 180 degrees is 0. Then minus tan 135 degrees can be written as tan 180 degrees minus 45 degrees, right? Then here we have cos theta, then negative and negative is positive, sine theta, then that over negative tan in the second quadrant is negative, so we have negative tan 45 degrees, right? Because tan in the second quadrant is negative, and we also have this negative outside here. Then we'll be left with cos theta plus sine theta, and then what is negative times negative? That's a positive. But what is tan 45 degrees? That's 1. So cos theta plus sine theta over 1 is equals to cos theta plus sine theta. Okay, so now let's look at G. We have cos 330 degrees, which this one is in the fourth quadrant, can be written in the reduction formula cos 360 degrees minus 30 degrees. Then we have sine 140 degrees, which we can see it is in the second quadrant, can be written as sine 180 degrees minus 40 degrees, right? And then all that over we have sine negative 160 degrees, which we can see that one is a negative angle. So how do we write that one? Sine of a negative angle, we know that it is negative sine, so that's negative sine 160 degrees. Then we are given tan 405 degrees, which we know if an angle is greater than 360, we need to subtract 360 from it. So 405 degrees minus 360, that will give us tan 45 degrees, right? Then we have sine 290 degrees, which we can see this one is in the fourth quadrant. But remember, in the fourth quadrant, we are avoiding using the reduction formula 270 degrees. So this one we always want to avoid using 270 plus theta in the fourth quadrant, and we also want to avoid using 270 minus theta in the third quadrant. So always note that. That means we'll only use the 360 minus. So having to write this, we have sine 360 degrees minus 70 degrees. Okay. Now, how is cos in the fourth quadrant? We know cos is positive, so this one will come out as cos 30 degrees. And then having to deal with this one, how is sine in the second quadrant? It is positive, so we have sine 40 degrees. Then over this one, let's write it in terms of reduction formulae, because we can see that we have that non-acute angle. So this is 180 degrees minus 20 degrees. Then tan 45 degrees, what is it? This gives us 1. So let's just write 1. And then sine 360 degrees minus 70. We know sine is negative in the fourth quadrant. So this comes out as negative sine 70 degrees. Now let's go. What is cos 30 degrees? Cos 30 degrees, according to our right angle triangle of special angles, gives us √3 over 2. Right. Remember, they'll be saying without the use of a calculator. Then we have sine 40 degrees. Let's write it, sine 40 degrees. Now dealing with the numerator here, this is negative sine 180 degrees minus 20. So we know sine in the second quadrant is positive, but we have this negative here, so we're going to write sine 20 degrees. Now let's go to this one. 1 times this is that, then negative sine 70 degrees. This can also be written as negative sine. Reduce it in terms of the reduction formula in quadrant number 1. This is 90 minus 20 degrees. And why are we doing this? Because we want to change it to this 20 degrees. Remember, we are trying to find the relationship between these numbers, right? And then this is root 3 over sine 40 degrees. And then below here, what do we have? We have now negative, and a negative is positive, so we have sine 20 degrees. But remember, this one is a cofunction, so it changes to cos 20 degrees. Now if you look at this, you can see that it is almost similar to what we have as the double angle of sine. So sine 2 theta is equal to 2 sine theta cos theta, right? So you can see that it is almost similar except for this 2 here. Now we can do something with this though. If you can look at this 40 degrees, this is exactly the double angle that we are speaking about here, right? So 40 degrees is a double angle of 20 degrees. So this sine 40 degrees can be written as 2 sine 20 degrees cos 20 degrees. So now let's go. We have for that one we have this root 3 over 2, and then let's break this down into the double angle 2 sine 20 degrees and then cos 20 degrees. Awesome. Then over we have sine 20 degrees and then cos 20 degrees. At this point we can see that we have obtained the relationship between the numbers. The numbers are now the same, that we have sine 20 up here and then sine 20 down here. Cos 20 cancels out with this cos 20. Now we are left with root 3 over 2 multiplied by 2, which we can see now the 2 and the 2 will cancel out, so our solution is root 3 once again. Okay, so now let's look at H. The question that we have, it says root 2 cos 75 degrees minus 1, and then 1 plus root 2 cos 75 degrees. Now if you can look at this, you can see that we have a minus and a plus, and all that is written in this bracket, in these two brackets, are the same, so we can classify this as difference of two squares. Now let's write it in a form that we are used to, so that we see that it is truly difference of two squares. We have root 2 cos 75 degrees minus 1, and then now let's try to write this as root 2 cos 75 degrees plus 1. So this doesn't change anything because it's just a matter of changing the positions. Now I put the 1 here, and then the root 2 cos 75 degrees becomes the first term of that second bracket. Right, at this point we can see that this is difference of two squares, since we have the same contents in the bracket, but then it's only a difference of this signs here. So now having to multiply here, we have root 2 times root 2. That will give us 2 cos squared 75 degrees. Remember, the cos 75 degrees times cos 75 degrees gives us cos squared 75 degrees. Note how we write it. We say cos squared 75 degrees and not cos 75 degrees squared. So note the way we write that one. And then having this one, you take that one, multiply by that one, would be positive, and then this one multiplied by that would be negative. So we know with difference of two squares we don't have a middle term, because they will cancel out. The middle terms will just cancel out. So now we can just look at the last terms. It's negative 1 times positive 1. That will give us negative 1. Now if you can look at this, you can see that there is a certain double angle that looks exactly like this. We have cos 2 theta, which we know breaks to 2 cos squared theta minus 1, right? So if you can just look at your formula sheet, you do have something similar to this, which is quite similar to what we have here, 2 cos squared 75 degrees minus 1. Now we know that the theta here, when we trying to change it to the double angle, now we must multiply by the theta by 2, because here we are putting a double angle. So this will give us cos 2 multiplied by 75 degrees, which we know this will end up being cos 150 degrees, which we can all agree that this is a double angle of 75 degrees. It's twice 75 degrees. But then remember, 150 degrees is a non-acute angle. That means we can change it in terms of the reduction formulae of the second quadrant. So we have 180 degrees minus 30 degrees, right? Now having to solve this one, this will give us how is cos in the second quadrant? We know cos in the second quadrant is negative, so we have negative cos 30 degrees. Now our triangle of special angles will give us the value to that one. So if you are wondering what I've been speaking about, this is it. We have our 60 here, we have our 30 here, and then we have our 2 here, our root our 1 is here, and our root 3 is there, right? So this is how it goes. So cos 30 degrees will be adjacent over hypotenuse, right? So this will give us negative root 3 over 2, right? So that one becomes your solution. Awesome. So let's attempt I. We are given sine 33 degrees over sine 11 degrees minus cos 33 degrees over cos 11 degrees. Now from this we can see that our LCM, multiplying these two denominators, our LCM is sine 11 degrees cos 11 degrees, right? Then if we take all of this, sine 11 degrees cos 11 degrees, divide by sine 11, you can see that sine 11 and sine 11 will cancel out, and then we'll only be left with this cos 11, which will multiply with the sine 33 in the numerator. So we have sine 33 degrees cos 11 degrees. Then also if we take all of this divided by cos 11 degrees, cos 11 degrees and cos 11 degrees will divide out, so we'll be left with this sine 11 degrees to multiply with this cos 33. So we have cos 33 degrees and then sine 11 degrees. So at this point we have sine 33 degrees cos 11 degrees, and then at this point we can see that we have a situation of a compound angle, right? So what compound angle looks similar to this one? So if we can just check here, sine A minus B from our formula sheet, this gives you sine A cos B minus cos A sine B, which we can see that we are seeing a similar situation here. If your A is 33 and your B is 11, you can see this is your A, this is your B, and sine cos, cos sine. So this is a similar situation that we see here, whereby we know we need to take all this in the right hand side and reduce it to this 1 trig ratio. So that means we have sine 33 minus 11 degrees, then over sine 11 cos 11 degrees. Then what is 33 minus 11? That gives us sine 22 degrees, and then over sine 11 degrees cos 11 degrees. Now looking at this, you can see that this one is a double angle. We have a situation of a double angle where we know sine 2a is equals to 2 sine a and then cos a, right? Now, having to break this one, it will be 2 sine 11 degrees. Remember, the angle here needs to be half this. Then sine 11 degrees and then cos 11 degrees over sine 11 degrees cos 11 degrees. So what happens to our angles now? They cancel out. So all these trig ratios, they cancel out, and then we are left with 2.